So basically, here's the deal. This is going to be, we're going to teach this. Normally we would teach this over a week. We're going to do it in 37 minutes. Okay? Yeah. So here's the deal. At the bottom of your reference sheet is this. It's called the standard normal curve. It's a bell curve. Everybody in here has heard of a curve before? Yeah. Okay. So basically, here's what takes place. We talked about probability, right? Things that are binomial probabilities, when you try and graph them with a frequency histogram, they will look like this, right? You drew this in ninth grade algebra? Yeah, you did. Histograms, they don't have bars in between them, bar graph. So somebody, then when you try and connect them and make it like, draw a curve on them, do you see what it produces? This thing right here. And then we also talked about probability in terms of it being an area, right? Remember how we did that really long problem and the guy converted probability into a square, and then we tried to find the little piece of the square as opposed to the big long piece? So what that proved is that probability can be viewed as a shape. So this curve right here is called the standard normal curve. And so if things have a binomial probability, this is actually the shape that they produce, this bell-shaped. It's not a square. And you can use it to make predictions about the world around you. And what happens is the following. The middle of the curve, this spot right here, this is the mean of whatever survey or collection of data that you have. And then going outwards, each of these spots is a standard deviation. Okay? That's +1 standard deviation. This is -1 standard deviation. And it turns out all you really need to do is go 3 standard deviations away from the center, and you can accurately make a prediction that is 99% correct about a population. Do you know what I mean? So when you are doing marketing or research, is it really viable? Is it really possible to survey every single person? It's not. It's impossible. It would take a lot of money to do that, and it's probably take a lot of time. So what they found from doing research is, if you structure a study in a particular way, and you learn about that in AP statistics a lot more than you do in here. We're going to talk about it a little bit in here. If you structure a study in a particular way, then using this curve, you can make predictions about their preferences, or probability-wise, what will take place. All right? So, the single most important thing that you need to take away from today is the following. You need to remember that if we say the words normal distribution or standard distribution, it means a bell shape. And you have to remember this day of May. Remember the 64%, 95%, 99% rule. Oh, I'm sorry about that. Not 64, 68. 68. Where do we get this rule from? We get it from above, from the bell shape. If you are within 1 standard deviation on either side of the mean, you will collect 68%. You will be, the population will fall, 68% of the population will fall in that range. If you go 2 standard deviations away, you will catch 95% of the population. And finally, if you go 3 standard deviations out, you will catch 99% of the population. Let me give you another example before we get started with this sheet. You see that this school is extremely different and diversified, right? We have a whole range of people in here from every culture, every ethnicity, ever, right? I bet I can give you a description which will capture 95% of them. Yeah? Let's call you guys the average, the mean, okay? Give me a description very briefly of people that are above you in terms of academics. Not by name, but like let's talk about them. Like honors, AP classes. You know what I mean? Okay, that's a bit above, right? Let's just say that that's 2 standard deviations above, right? People taking honors and AP classes are 2 standard deviations above. Yeah? Now let's go below you guys. People, just in general. Just in general. Now let's talk about people 2 standard deviations below you guys. Probably not passing and taking 1 night school class. Do you understand? By giving that description, would you agree with me that 95% of the people in the school fit in that range? Yeah? That's what I mean. That's what this curve allows you to do. It allows you to predict about a population. What's up? Okay.
Based on the amount of standard deviations you go out, that's the amount of
Yes.
what that.
You are dead on. Okay, let's do this first one. This is this first one, and we're working off a sheet today. In a standard distribution, and if you see those words, it means you can use a bell curve. In a standard distribution, what is the greatest percent of the data that falls 2 standard deviations away from the mean? X bar is a really fancy way of saying the mean, right? Suppose I go minus 2 standard deviations to the left and plus 2 standard deviations to the right. The area underneath is 95% of the whole shape. That's it. That's all there is to it. So, what is a standard deviation? So let's talk about it in terms of, what is it? It's a standard distance away from the average. That's what a standard deviation is. So let's do question number 2 now. You'll understand more. The national mean for verbal scores on an exam is 428. So the national mean for verbal scores on an exam is 428, the national mean. So 428. This is used for SAT scores as well. It's also used for your Regents exams. This is how they create a curve, like for your algebra test. You know what I mean? So the standard deviation is 113. Approximately what percent of those taking this test had verbal scores between 315 and 541? So here's what you do. You mark down the mean. You mark down the other scores, 315 and 541. And then you say to yourself, what's the distance between these scores? How far away is 315 from the average? No. How far away, like actually in terms of a number? What happens if you subtracted them? This is 113 away. And 541, how much is it away? But 113 is 1 standard deviation. So really another way of saying the same thing is this is 1 standard deviation above, and this is 1 standard deviation below. Okay? And so this is 68%. You get it?
Yeah. Okay, I got it.
So here's what I mean, right? 1 standard deviation in either direction. You can remember the rule, or you can literally go to your chart and add all of this up. If you add all of these numbers up, right, it gives you 68%. 68.2, sometimes they're a little bit off. Statistics and probability is all about being up, like, as close as you can. Oh, because in the directions it says each standard deviation is equal to 113. Yeah. Now let's step our game up a little bit. Let's step our game up a little bit and do number 3. So let's do number 3. Let's do number 3. Okay, they're all going to follow the same kind of order, though. Let's do 3. What's the average? What's the mean? Good. 64.3 is the mean. And now we're going to find out. Okay, so now it says the standard deviation is 5.4. What's the best approximation for the scores that fall between, well, what is the best approximation of the percent of scores that fell between 61.6 and 75.1? So once again, then first thing you do is you find out how much space is between these numbers. Who has their calculator and can tell me this? Lou? Phil, do you agree with this? Okay. So this is minus 2.7 below, and this is what? Plus 10.04. And how much is each standard deviation? Sorry, this is 10.8. Sorry about that. This is 10.8. How much is each standard deviation? 5.4. If each standard deviation is worth 5.4, how many is 10.8? This is plus 2 standard deviations. What about this one? No, chill. Minus a half. This is minus half of a standard deviation. And so, Mick, you asked me, would we get other percentages, right? This is why they give that chart to you on your reference table and why they split it up. Let me grab the chart for a minute. Here's my chart, right? I am half of a standard deviation below. Let me grab my highlighter. Half. So you go 0.5 below, and we want to go 2 above, and then you add all the numbers in between. That's what you do. That's it. That's all you do. And I actually can add them in my head. Look, 19 plus 19 is 38. Okay? I know there's that 0.1. I'll add it on extra. It's like, yes, it's on your reference table. So this is like 38 and 15 is what? 48, 53, 53 and 9 is what? 60, 62. 62 and 4 is what? 66. What's the answer on your sheet? What's up? 66.8, right? So with relative like certainty, I could tell you that this is 66.8%. Okay. You like that? That's as hard as it gets. That's what you have to take away from today. 2.7. The scores on an exam have a normal distribution. You see those words, what does it mean? Bell curve, good. The mean for the scores is 50. So you put 50 in the middle every time. The mean for the scores is 50 and the standard deviation is 4. What is the best approximation for the percentage of the students who can be expected to score between 46 and 54? So 46, 54. Now, if you want, you can go look up on your chart. How much is each standard deviation? Each standard deviation is worth 4. So we are talking about up 1 SD and down 1 SD. And what do you know without even looking on your chart? Yeah, you guys got it. It's 68%. You good? Let's do one that I know I would like for you to be able to do. This was once a Math B Regents question. Everybody to go to question number 14. And if you're taking physics, I know you're learning about batteries right now. What? 15. 14. Valentine's Day question. Valentine's Day question. Okay. 14. For real quickly, just so people on the internet could see. Battery lifetime is normally distributed, right? Normally distributed. That means there's a bell. And it tells you the average number of days a battery lasts is 500. The standard deviation is 61 days. Approximately what percentage of the batteries will last longer than 561? Go. Yeah, longer. Yeah. So what's the distance between these two numbers? 60. It's plus 61. And so how many standard deviations is that? It's one standard deviation. So you just go to your chart. You just go to your chart. It's great. Guys, you go to one, you go grab your chart, you go one standard deviation, and you want to add all of this.
So is the answer 4?
No. The answer's dude, why can't we just, why are you doing it so complicated? Why can't we just take out our calculators and add 9.2 plus 4.4 plus 1.7 plus 0.5 plus 0.1? Dude, it's 16. It's choice 1.